Hi, I'm MJ White, and today I will be presenting on using IC-ICP-MS to detect arsenic species in soil. The main research that I'll be covering is in an article called Extraction of Arsenic Species in Soils Using Microwave-Assisted Extraction Detection by Ion Chromatography coupled to Inductively Coupled Plasma Mass Spectrometry. And this research was done by Rahman and Associates. So first let's cover some background. What is arsenic? So arsenic is element number 33 and it has a mass of 74.9. And arsenic comes in a wide variety of species that are naturally found in the environment. And these species can be either organic or inorganic. And the organic side would be MMA or DMA. MMA is monomethyl arsenate and DMA is dimethyl arsenite. And these are not extremely toxic, especially in small amounts, and these are just common metabolites. But on the other side, we have the inorganic species, and examples of this would be arsenite and arsenate, and these are very toxic and can be human carcinogens. And so it's naturally found in soil, which then affects groundwater and can be poisonous to humans and cause skin conditions like on the hands shown in the presentation, and even cancer. So arsenic contamination in drinking water harms many people across the globe, as you can see on this map. And Bangladesh is one of the worst locations that has this issue, and they're in a water crisis right now. And even before 1970, because of this issue, they had the highest infant mortality rate. And so it's a very serious problem there. Even UNICEF and Chemists Without Borders are trying to help this situation. And if you look at this pie chart, 16% of their water is unsafe, 39% is safe, and 45% has never been tested, which is why accurate determination of arsenic in the environment is very important. So the goal of this research is to accurately determine the concentration of arsenic species in Bangladesh soil samples. And in addition, they wanted to determine an efficient extraction method to do this on a regular basis. So let's start with what did they use to complete this research. So they had standards. They used 4 standards, each dissolved in deionized water. And the first was arsenite, and then arsenate, MMA, and DMA. So they used 2 inorganic standards and 2 organic standards. They used a phosphate buffer prepared from ammonium dihydrogen orthophosphate, and they adjusted the pH with ammonium hydroxide. They used digestion solvents, and they used nitric acid, and hydrochloric acid. So the researchers in this study collected 20 soil samples from contaminated irrigation water in Bangladesh, areas that they already knew were affected by arsenic. They used 0.2 to 1 grams of the soil and mixed it with 5 milliliters of the digestion acid, which was the nitric acid or the hydrochloric acid. And efficiency of extracting arsenic species from soil depends on 2 things. First, the extraction system, and second, the extraction solvent that they needed to use. So first, I'll start with the extraction system. So they used microwave-assisted extraction, or MAE, and this is an automated approach that applies pressure and temperature during extraction, and this makes it faster and less labor-intensive than alternative methods. And the second area is the extraction solvent. And so they tested 3 different solvents for extraction: orthophosphoric acid, ammonium dihydrogen orthophosphate, diammonium hydrogen orthophosphate. They discovered that orthophosphoric acid was best with a 67.2% recovery, as you can see in this table, comparing the 3 solvents. And this particular solvent was best because it could react better with the inorganic species when it extracted them because of its acidic pH levels. And this was good because since we're focusing on the inorganic species, since they're the most harmful, this is why this solvent was the best to use. And so we microwaved the solution at 60 watts for 10 minutes, and then this digested solution was then transferred, diluted to 50 mils, and filtered once more before it was analyzed. We're using IC-ICP-MS in this case because of its multi-element capabilities. And so before we can use it on the environmental soil samples, they needed to test the validity of using this instrument for the soil samples. And to do this, they used Montana soil because of its arsenic levels. And so they used the same exact extraction process, so the microwave-assisted extraction, and their result was 102.1% recovery, which is really good. So we can conclude that this procedure can be applied to the environmental soil samples in order to determine the concentration of arsenic in the Bangladesh water. And so there's only one main problem with using IC-ICP-MS, and that was that they experienced some interferences. And so we can expect to see an arsenic peak at a mass to charge ratio value of 75 because of its atomic weight or molecular weight. And so they saw an interference from a polyatomic species, argon chloride, at 75. And so their solution was to spike ammonium chloride solutions with arsenic species and see how they elute. And you can see here that all 4 of these species eluted before 8 minutes, while the chloride ion eluted at 9 minutes. And so here they concluded that chloride did not interfere with the arsenic determination by IC-ICP-MS. So now let's talk about the instrumentation specifically. They use instruments by Agilent Technologies, and so they used Agilent 1100 liquid chromatography model coupled with the Agilent 7500C ICP-MS, and they used a Babblington nebulizer with a Scott spray chamber for sample introduction. And these instruments coupled together are the most often used hyphenated systems for speciation analyses. So when the 4 standards were tested for their efficiency, they got an extraction efficiency ranging from 73 to 85%, and so that can be applied to our environmental samples, and that's what we can expect to get. So moving on to our data and results. Table 6 here shows the Montana sample as well as the 20 Bangladesh soil samples, all reported here, and this table reports their concentration of each arsenic species in each sample as well as the percent recoveries. So the results show that there was no MMA or DMA found in the environmental soil samples, and the main species that was found was arsenate, which here on the table it's listed as arsenic 5. And there was only arsenite found in 9 out of the 20 samples, which here arsenite is arsenic 3. And it's important to note the significant differences in arsenic extractability observed in the study are due to the higher values of iron, aluminum, and manganese in the soil sample. Next we have a spectrum of the data, and here we can see that there was in fact a peak at a mass to charge value of 75. So the conclusions. So in terms of the Bangladesh soil samples, like I said before, there was no MMA or DMA found. Arsenate was found in all 20, and arsenite was found in 9 out of the 20. And they reported that this could be the result for the arsenite because it partially oxidized to arsenate. And in terms of the procedure, MAE, or microwave-assisted extraction, coupled with the orthophosphoric acid as the solvent, was an efficient extraction method. The only problems they saw were problems with various soil matrices, and they would need to further validate the accuracy of this process in the future. And with the IC-ICP-MS, they used it successfully because it was able to separate the signals of interest from the interferences with high detection power. And so, in closing, they were able to ID the harmful species of arsenic, the inorganic species, in the soil samples. So their research was effective in what they were trying to do, but it's not yet complete. So their further direction for their studies, they want to do further studies to understand the behavior and stability of arsenic species, specifically to understand the partial oxidation of arsenite. They want to test the actual irrigation water in Bangladesh, because here they were only able to test the soils around the water, because at the time that they were there doing research, the irrigation system was closed down. And they want to test the untested areas of Bangladesh, because like we saw in the pie graph at the beginning, 45% of Bangladesh areas are not even tested yet. So that's where they're going with their research. Thank you for listening to my presentation, and here are my resources. Thank you.